In this video, we are going to see what an elementary function is, how to graph it, and also how to transform. That is, you shift it either to the right, left, move it above or below. There are 6 basic functions. We have an identity function where each element x is mapped onto y. X and y are one and the same. That is, 1 is mapped onto 1 itself. 2 is mapped onto 2. 3 is mapped onto 3. So that is an identity function, and the graph looks like this. The square function is y equal to x squared, or h of x equal to x squared, and the graph will look like a parabola. A cubic function is y equal to x cubed, and the graph looks like this. A square root function is y equal to square root of x, and the graph looks like that. The cubic root is y equal to cube root of x, and that's a graph. An absolute function will be y equal to absolute value of x, and that is the graph. So if we want to get these graphs, we can just enter this under y1 or y2, y3 in our graphing calculator and get the result. In order to get the absolute value of x, we can select in our calculator, we can select math. Under that, if we go for numbers, the absolute option is there, so we can make use of the option absolute, ABS, absolute value, and that will create the curve easily. Let's talk about the transformations. The first one is the vertical shift. The function y is equal to f of x is defined, and if you add k to this y, that is f of x plus k, then it looks like it is moved up to k units. That is, if a function f of x is given like this, it will be shifted vertically upward to k units. In this case, if I'm adding 4 to this, it will be shifted up to 4 units. The same way, if I subtract negative k, it will be shifted down to the same unit. Whatever I have, minus 5, so it is shifted down by 5 units. The other transformation is the horizontal shift. You can either shift it to the right or to the left. If I add a constant to x, not to y, but x, it is shifted to the left. That is, if the function f of x is given like this, your x plus 4, absolute value of x plus 4 will be shifted to the left by 4 units. And if I subtract a constant, that it will be shifted to the right. That is, x minus 5, absolute value of x minus 5 will be a curve which will be obtained from the previous one by shifting it to the right. So in general, if I have a function f of x, the vertical translation is by adding k to y, that is f of x plus k will be a vertical translation. If k is positive, then it is shifted up to that k units. If k is negative, it is shifted down to k units. If I'm talking about the horizontal translation, horizontal shift, then I have to add a constant to x, not to y. If h is positive, the one whatever you have added is positive, then it is shifted to the left. If it is negative, it is shifted to the right. We can also enlarge or contract the function by multiplying the function by a constant a. But there are 3 different cases. If the constant with which you're multiplying is greater than 1, like if I'm multiplying by 2 or 3, then it looks like it stretches. If it is a fraction, positive fraction, that is if it is between 0 and 1, then it shrinks, it contracts. If it is exactly -1, then it is a reflection. It flips on the x-axis. We can also talk about the piecewise function, where there are two different stages. It is split. There are two pieces of this function. One, it is defined as x plus 1 in the interval 0 to 2, 0 is included, 2 not included. 0.5 when x is greater than or equal to 2. So when you are drawing the curve x plus 1, you draw it between 0 to 2. At 2 it is not included, so use the open circle just to say that it is not included at the point, but it is closed, so you have a closed dot there. For the other one, 0.5x, here the starting point is included, so it is a dark circle, and there is an arrow because it extends, it goes up till infinity. So at the point 2, 3, the function is not defined. See, 2 is the x value and 3 is the y value. At the point 2, 3, there is a discontinuity at this particular point. We can also graph it, the piecewise curve functions, using a graphing calculator. For example, let us take this function x squared when x is less than 2, 9 minus x when x is greater than or equal to 2. We know that y equal to x squared is a parabola, and it stops at 2 less than 2 only you have the parabola. So you will have an open circle at 2. And the line 9 minus x can be drawn after 2, and it goes up to infinity, so there is an arrow. If we want to draw that in a graphing calculator, then let us enter this in our y1. We can enter both together with these parentheses, x squared when x is less than 2 and y minus x when x is greater than or equal to 2. We have these logical statements, less than 2 and greater than or equal to 2. So we can find those symbols in your calculator when you select your test. That is, second math is your test. So under test, we can find all these inequality signs, greater than, less than, greater, equal to, etc. We can make use of this, and in order to have a discontinuity, instead of taking this as connected, let us use dots so that there won't be any continuous curve there. You can see the gap, the discontinuity at the point 2 clearly. So this video helped us to understand what a function is and how to graph it, various types of functions, and how the graph looks like, and how to graph that using a graphing calculator. Hope this video was helpful. Thank you for listening and thank you for watching.